to RemedialOne YouTube channel. In this video, I'm solving question 8 of WASSCE 2022 Novdec. That's for private students. So let's start. A uniform beam PQ of length 110 centimeters and weight 60 Newton is suspended on a pivot 50 centimeters from Q. It is kept in equilibrium by forces T and 25 newtons applied at R and then S respectively, where PR is equal to 20 centimeters and then QS is 15 centimeters. We have to find, correct to 2 decimal places, the value of T. Now, questions of this nature, you need to draw the diagram. Okay, let's see the diagram. This is the diagram. The beam is PQ and then the weight is 60 newtons and the weight is always at the middle. So if you have 110 centimeters beam, then 55 centimeters will be where the weight will be positioned. So that's why the weight is at the 55 centimeters. Okay, and there is a pivot which is 50 centimeters from Q. So this is Q. So from this point to Q is 50 centimeters. Okay, but we were told that PR is 20 centimeters. So this is PR, so 20 centimeters. But because the width of the beam is at 55 centimeters, it means that, so if here is 20 centimeters, from R to the width of the beam will be 25 centimeters. And then the pivot is 50 centimeters from Q. So, which means that from the width to the pivot will be 5 centimeters. Okay. And then QS is 15 centimeters. So if here is 15 centimeters, it means that from S to the pivot will be 35 centimeters. Okay. So taking moment at this pivot, you can say that, well, we can change this one to centimeters. Remember, 100 centimeters is equal to 1 meter. So bear in mind, taking moment at the pivot. So on the left side, we have this T from the pivot, T to the pivot. Here is 35, here is 4, so we have 4 centimeters. So to change it to 40 centimeters, to change it to meters will be 0.4. So we have T times 0.4 plus, and then this 60 to the pivot. 60 times, this is 5 centimeters, and 5 centimeters to meters will be 0.05. On the other side, we have this force here, and from this point to the pivot is 35. So that will be 25 newtons times 0.35. So that is the setup. Let me remind you that we are using the principle of moment. That is, clockwise moment is equal to anti-clockwise moment. So that is the principle that we are using here. So we have, this will be 0.4t plus 60 times 0.05, this will be 3, and then 25 times 0.35, this one is 8.75. We want to find t, so let's move this one to this side. So 0.4t will be equal to 8.75 minus 3. This implies that 0.4t will be equal to, and this is 5.75. So we divide both sides by 0.4. So our t becomes, when you divide, we are getting 14.38 newtons. Okay. So let's see how we are going to score it. Now for a diagram indicating all these items, the tension, the weight, the distances, we have B2. And then for taking moment, this one is M1. Then correct, we have A1. And finding M, finding T, we have M1. And Then final answer T is equal to 14.38 newtons. Get another A. Viewers, thank you very much for watching this video. If you are watching me for the first time and you have not subscribed, kindly click on the subscribe button. You can also turn on your notification button so that anytime we post a video, you'll be alerted wherever you are. So next will be question 9. So don't forget when you get that alert. Bye.